All right, afternoon everyone. I'm Ian and this is Tash. We've spent the last 2 years making Diggit, which is a digital recording system for field archaeology. My background is in archaeology and learning design, and Tash's is in programming and data science. And on this beautiful sunny day, we've got you all inside here for the next 20 minutes after lunch so we can talk to you about data standardization. I'm so sorry. It's not the sexiest topic in the world, and it doesn't really give you much vitamin D, but it is a really important topic for the industry of archaeology, not just in the present, but also for its near future too. Before we get started, big disclaimer here. Every single person in this room has more experience of this industry than us. But there will be some sweeping generalizations in this presentation, for which many of you will have some fantastic examples to the complete contrary. But these generalizations are representations of the outside perspective looking in, so there's still some validity to them, at least for others. Now that I've put on that Kevlar vest, let's get cracking. Okay, so there's 3 parts to this presentation, should be about 20 minutes. We'll start by looking at what data standardization is and why it's so important. Then we'll move on to look at why it hasn't really been achieved before in archaeology. Then we'll talk a bit about what we've been doing with Diggit and how that might address data standardization. And then hopefully at the end we might have time for a couple of questions. All right, so what is data standardization and why is it so important? To answer that question, it's best to kind of consider the industry as it is without data standardization. And to do this, to illustrate some points, we're going to imagine 4 archaeology companies. Each one of these companies, each one of them is producing data in completely different formats. Company A is exporting all of their site data as, well, it's on paper in LibreArch files. Company B is typing theirs up on Word and Excel. Company C's archaeological findings are all put into read-only PDFs, and their surveying data is saved as SVG files. And Company D, of course, prefers CAD files. Now, all 4 of these companies are doing the exact same job with completely the same purpose. But when they're sharing their results, these different data formats mean it's a little bit like they're speaking different languages. And this is where we're at without data standardization. It's difficult to do anything with one another's results unless we translate them all into the same output format and standardize the data. And when this data is standardized, it brings a lot of significant advantages to each company. The first and most obvious of these is collaboration. With large infrastructure projects like HS2, collaboration is important. You need a lot of archaeologists, and sometimes one company can't provide all of them. And if you've got data standardization between the 2 companies working together, then they can easily share the data as they're recording it, and also easily share it with the clients and other interested third parties. Standardization also benefits communication between all of us. Everyone here will have been working in a company where you've been doing an open area site, and you've inherited that from a different company who was doing the trenching evaluation. And if that trenching evaluation, if all the data from that was put in the same format that you use in your own company, it would make everything that much easier to get started quicker and to make sure you're not digging in the wrong place. And I know that last bit sounds a bit silly, but a friend of mine who's a supervisor once spent several weeks on an open area site, and it was a Roman site, not really finding many finds until they got a really significant small find at the bottom of a Roman pit, which was a 2008 prescription bottle. And that point was when they realized that actually there had been archaeologically excavated in exactly the same area before by a different company. Now, if there was standardized data and it was easily accessible, these kind of time vampires just wouldn't happen to us. So it can really benefit communication. And lastly, reinterpretation. We've talked a lot about archiving. And really, the whole point of archiving is so that future archaeologists and researchers can continue the work we've done and build upon it, or add future insights to it to learn more from it. But it's actually, in reality, it's quite difficult for that to happen. If a lot of our data is on paper and it's in LibreArch files, well, you think about how many context sheets there are on a site, for example. That's a lot of raw data and a lot of paper that no one realistically is going to flick through. If this data is saved digitally, it's better. But if it's not standardized, it's still difficult to import into your own working practices and get going again. But if we can have data standardization, and I'm going to be saying those 2 words a lot today if I haven't already, if we had data standardization, it would allow us to more seamlessly progress the work of others and push our research further. There's also the issue of our unity as an industry. Now, without data standardization, we're all speaking in different languages, and each one of us has our own small voice, and we're talking over each other. Trying to lobby the government on key issues that affect everybody, or getting the public to sit up and take notice, it is pretty difficult. But if we standardize our data, then boom, our findings gain greater significance, and we can speak together with one loud voice on issues that affect all of us. This gets people to listen, and this is how change happens. And by the way, standardizing data, it doesn't just create a big speech bubble, it creates big data. Now, what's big data? Essentially, it's when quantities of data are lumped together into groups that are so big that normal human beings, we can't really make sense of it. It's just too much. But if all this data is standardized as big data, then we can use software to spot the trends that are revealed throughout. There's trends, there's patterns, all kinds of things we can't see if we're trying to flick through context sheets. So big data is extremely important for our understanding of archaeology. And it's also the evidence we use to justify our industry-wide needs and discoveries. And speaking of discoveries, big data can help us better identify and track large-scale archaeological phenomena, and also trends, such as changing environmental circumstances, population migrations, the growth and flow of trade, and the evolution of technologies and fashions. In fact, there's so much more that we have yet to learn or even know we need to learn because we haven't got the big data there available and it's not standardized. So there are loads of reasons why we'd all benefit from data standardization. But if the benefits are really that obvious, why hasn't it happened yet for archaeology? Well, actually, there have been plenty of moments where we have been standardizing our outputs, but it tends to look like this. We continue recording using the systems that we always have done, and then we all export our stuff in our preferred formats. And then once a job's finished, the client or interested parties come back and say, right, can you standardize that, please? So we go back and we spend time and we standardize it, and then it happens again and again and again. It's complicated, it's laborious, it's repetitive, and basically it's by retroactively standardizing our output, it's like we're playing a giant game of whack-a-mole, right? Except every whack takes several weeks and can cost up to a few £1,000s. Understandably, that is a game nobody wants to play. There is a better alternative and an easier alternative to standardizing the output every time, though. And that's standardizing the input. If everybody was to be using a unified, standardized digital recording system, then the output just takes care of itself every single time. Seems simple, but as we learned, it really, really isn't. There are lots of complex reasons why archaeology hasn't had one of these yet, and that's a whole other presentation. So we're really just going to look at a couple of the main ones. And the first is that the kind of software companies that could develop something really powerful for us, they're just not interested. And you actually, it sounds harsh, but you can't blame them, right? Archaeology is seen as a comparatively small and heavily fragmented industry. Also, our needs are incredibly subject-specific and complex. They're almost impenetrable to an outsider unless you have to speak for a long time. And even then, they'll say, okay, how long will it take us? You know, what's the market cost? What's the benefit? This is why big companies aren't really going to make something for us. But we all kind of know that, which is why we've been seeing something pretty exciting over the last 5 years. And that's that some of the bigger archaeological units have been developing solutions. Now, as someone who loves archaeology and is a massive nerd and loves tech, this has been so cool to see. I've been looking at all the different CIFA presentations. Every time someone shares about their recording system, we're glued to it. We plug it into the TV, watch on a big screen. And it's fantastic what these companies have been doing, and they've really been pioneering and leading the way for everyone else. I really believe that a rising tide lifts all boats, or something to that effect. And basically, by these companies pushing digital recording, it's got everybody to turn and look at the benefits of it, because it really is the future of our industry. So that should absolutely be applauded. But there are issues with some of the things that we've been developing. Now, big sweeping statements here, so don't worry, but some of the software that we're using to make these solutions, that wasn't designed for archaeology at all. In fact, most of it is office-based software. And this comes with intrinsic limitations. It has challenges in terms of complexity, connectivity, and compatibility. And again, that's another presentation. But the limitation of this software is one of the problems with it being ubiquitous, becoming ubiquitous, one hurdle there. And another issue is commercial archaeology itself. Commercialization allows companies as individuals to experiment and innovate. But if an individual company was to develop a digital recording system that gives a significant competitive advantage, for example, if it makes our workflow a lot faster and saves a lot of time, and make no mistake, a good digital recording system absolutely does that. Well, then there's no incentive to share that, because as companies in archaeology, everybody survives by the work that they win tenders for. So sharing this kind of innovation with competitors doesn't make any business sense. Again, there are cases where this is happening anyway, and it's brilliant. So these are two of the bigger problems as well. So what's the solution to each of these? Well, in terms of Office software being reappropriated and its limitations, the solution to that is to code something from the ground up specifically for archaeology. And with regards to the competition issues, it needs to be done by someone independently. Well, the perfect people to do that are big tech companies. And unfortunately, they're not interested in archaeology. And this cycle perpetuates. And this is something that I think is responsible for why archaeology as an industry isn't as technologically specific as others. We use lots of great technology, drones, SFM, but we don't have any of our own stuff. And I think that loop is part of the reason why. So we've looked at why we need data standardization and the obstacles that prevented us achieving it. So what's the next step? Well, we've spent a couple of years building a solution to overcome these obstacles, and we gave it the cheesy working title of Diggit, which unfortunately stuck. Tash, are you able to tell us a little bit about that?
So Diggit is a reconfigured Office software. It's an off-the-shelf digital recording system that is custom built for archaeology. And it was independently developed without any affiliations, and it currently replaces the need for contact sheets and trend sheets. And the system is made of two components. There's Diggitmobile, a mobile app for recording in the field, and Diggitweb for exploring and exporting live-site data. And they both talk to each other via a cloud database. So let's look at how the system introduces data standardization, starting with Diggitmobile. So this is Diggitmobile, and this is our solution to standardizing the input. And we achieve that looking at 5 key principles. The first one is connectivity, because you can't achieve standardization if you're exclusive to one particular platform or one particular type of device. So Diggit works on all Android or iOS devices, whether they're smartphones or tablets. Next principle is ubiquity. For achieving standardization, you need to be able to use all your sites, on the small sites, the big sites, the trenching sites, the open area ones, and also the ones that are completely remote and offline versus the ones that have connectivity. So Diggit works everywhere. The next point is familiarity. There's no point reinventing the wheel when archaeology already has a recording standard. In fact, we haven't seen any manuals in the UK that aren't based on Molasses' original manual, and that's because it's brilliant. It has worked really greatly. I'm going too fast here. So we based Diggitmobile on the Molasses' original manual, and we incorporated some of the most common tweaks and updates that we've noticed in other manuals as well. Next is accessibility. Recording archaeology can be quite challenging. If you're new to the job, if you're a volunteer with no experience, if you've got dyslexia, if English isn't your first language. And in fact, we know from the State of the Market report that one in 7, I think, archaeologists in the UK aren't British nationals. So when you record archaeology, it comes with a lot of very niche English jargon, and that could be quite challenging. I can relate. So we designed Diggit with a supportive user interface. So it comes with helpful imagery and vocabulary shortcuts, so it guides the user through the recording process. Next, simplicity. If technology is annoying to use, then your staff aren't going to use it. They'll revert to paper, and then you won't have standardization. So we designed Diggit to be as intuitive as possible, recording in all your context with just a few taps. So that's Diggitmobile, and as I said, that's our solution to standardizing the input. Now, when connectivity is restored, so either you have internet on site, or you come back to your accommodation or your office and you've got Wi-Fi, the devices instantaneously sync with the cloud, and there the data is backed up on 3 different servers located in 3 different geographical areas. So the data is kept secure, and it syncs with Diggitweb as well for exploring and exporting your live site data. So let's have a look at Diggitweb now. Diggitweb, as the name suggests, is a web app. So you don't have to install any software on your computers. It's compatible with most modern browsers. And when designing Diggitweb, we focused on functionality. We asked archaeologists, what are the key tasks that you have to do on a daily basis, and how can we streamline this? So the interface lets you do things like viewing your site, exporting information, filtering, and so on. Let's have a look at it in action, actually. I think I've got it in big, whether you can see or not. So as a manager, you can view your sites, and here is an example of a particular feature we're currently implementing, which is viewing your sites on the map of Britain, or further afield, if you're lucky enough to dig in exotic places. You can view all your sites on the map, or you can view them as a table. So here you have a list of your current open and closed sites, the site code, and you can filter any of these columns. So for example, you can say, I just want to see my evaluation sites, and I want to see the ones where a particular supervisor was in charge, so you just type that, or particular project manager, and so on. And then you can click on your site, and then you can view your live site data. So this is data live coming from the field as it's being recorded, that was entered in Diggitmobile. And you can view the ones that are still in progress as well. So this is the ones that your staff haven't yet submitted. They're currently still in the process of recording it. And this is just an example of a particular table. This is the context register, but you have a list of tables you can view. You can view all your samples, your small finds, photos, drawings, and also 2 appendix tables, which are the context concordance table and your trench table. All of that is automatically generated for you. So here we have the context concordance table with description, some dimensions, your finds, and you can export all of these tables with 1 click as a CSV file. And then you can open that in Excel, you can put that in your reports. We tried to make them as report ready as possible, so you don't have to make much changes to the actual column names. And each column is filterable in every table. You can search, for example, if you're looking for a particular context and you knew it was in a pit, and it had maybe some bone in it, you can combine both of these search filters, and boom, you can find your context, the context in question. And these contexts, as well as the trenches, can be viewed as PDFs as well. So it automatically generates a PDF based on a template, and it fills all the boxes with the data that was entered. It translates it as natural language as well, as if someone had written them, basically. And that's the case, though, for context and trenches as well. So that's pretty much it for the site data. And if you click on sites, you go back to your list of sites, and we're back at the beginning. So a key aspect when designing Diggitweb was looking for simplicity, because we believe that you shouldn't have to be a computer nerd like we are to be able to explore and really visualize your site data. So that's why we designed Diggitweb to have a user-friendly interface. So that was Diggitweb, and Diggitweb is our way of standardizing the output, because as you may have seen from the demo, there are 2 types of outputs that we offer with Diggitweb. The first one is to meet the existing standard of the physical archive, so you can export everything as the PDF, which is a familiar format. But more importantly, you can export every data as tables, and in the format that we believe is the real digital standard, which is the CSV file. Because the CSV file can be opened in any software. You can open it in Excel, and you can view your context tables and your trench tables, or you can open it in your mapping software, like QGIS or ArcGIS. So you can bring all your archaeological data now alongside your survey data that you collected with your Trimbles and your Leicas. So with just a few clicks with Diggit, you can just view all your context data spatially. And we believe having both of these outputs is quite important, because often with existing solutions, there has to be some compromise to be made between either having report-ready tables or having pre-filled PDFs, but you don't really get to have both. So we wanted to make sure that you can do both of them with Diggit. And there you have it. I think that's the Diggit system and how it standardizes your data in a nutshell. I believe there's one more slide before the end of this.
I'll whisk through this one quickly. Basically, if you're using standardized data the whole time, then the future of how we interpret archaeology is tremendously exciting. On the screen here is a mock-up of a dashboard that we're developing at the moment. Now, if you've ever used a Fitbit tracker, a health tracker like a Fitbit or a Garmin, it measures your heart rate and your steps. And from those two metrics, when you log into your fitness tracker's account, you get all kinds of graphs about how fit you are, how it compares with other people in your age range, et cetera, et cetera. And that's with 2 data metrics. Well, like the average context sheet has, 50 data points on it? And the average site has a few hundred of those. This is a huge wealth of data. And the idea of the dashboard is that this is a window into all that data. You can get all key insights on one screen. And we think this is going to be tremendously useful for a lot of different situations. For example, you could have a supervisor who inherits a site from someone else because they go on holiday or elsewhere. And instead of going in cold and having to frantically ask around and look through LeverArch files, they can have a bit of a head start by just logging in and seeing this because it's live, it's updated live. And they can look at this and go, oh, right, okay, so we've got some structural archaeology here. There's a few masonry contexts. Right, we've got some human remains. Is that being looked after well? I'll need to check when I get on site. So it really benefits people inheriting sites. But also it's a great thing to share with county archaeologists, consultants, clients, to show progress in an easy way, in an easy manner. And the idea of a dashboard doesn't just benefit site-by-site interpretation. It could be really helpful for everyone as a company to see, if you had a dashboard for all of your work over the last 6 months, right, how much pottery have we got in the last 6 months? How does that compare with the past year? There's so many ways we can gain new insights if we standardize the data and visualize it this way. And this is only possible because of data standardization. So, sorry I went a little bit quick there, but I realize we're a bit pushed for time. There you have it. What data standardization is, why it can be so important to us, why we've not really achieved that yet, how we're trying to tackle that, and maybe we have time for a question or two. If you don't get to ask a question, that's my email address. It's a really spammy email address. I wish I'd named it something else now, but send it to inquiries, that's my name, and we will get back to you. So thanks very much.